Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called JS Whisper Yin Yang for Japanese Sum, German Whisper or Whisper 5 lines, and Yin Yang Shading, and it's by Yitrio. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits designated 9-cell region contains the digits 1 through 9 exactly once each. We have yin yang, where we need to shade some cells such that all shaded cells are orthogonally connected. So this would be an example of a valid yin yang shading. Shade some cells such that all shaded cells are orthogonally connected, all unshaded cells are orthogonally connected, and no 2x2 area is fully shaded or fully unshaded. So this is an example of a valid yin-yang shading. Actually, I think it's yin-yang. Yin-yang. I think that's the actual pronunciation, but I don't know why. I've basically Americanized it, I guess. Yin-yang shading, actually, I think it's actually the actual translation or the actual real pronunciation. But basically, what does it mean to be orthogonally connected? That means you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So for example, to get from this cell to this cell, you can go through these edges, all while staying within the shaded region. Same with these unshaded cells. You can get from here to here just by going down this path of going through edges, all while staying within the region. This is not a valid shading because to get from any of these cells now to any of the unshaded cells, you cannot reach there except by going through a corner or going through a shaded region, which is not allowed. And this would not be a valid yin-yang because this 2x2 area has an area that is fully unshaded. And those are examples of how yin-yang could work. The shaded cells act as a German whispers line. If two orthogonally connected cells are both shaded, then the digits in those cells must have a difference of at least 5. So, for example, if you have a 3 here, this would have to be 8 or 9, because the only remaining digits on these cells, the only digit which is 5 or more away from 3 is 8 or 9. And the thing is, I like to call them Whisper 5 cells because a setter came up with this designation, and I think it made a lot of sense because you can extend it to other types of lines like Whisper 4, Whisper 3, Whisper 6 lines, etc., etc. So if you hear me saying Whisper 5, no, it's the same thing as German Whisper lines. And finally, we have Japanese sums. And so, okay, so in the shaded part, you have the Whisper 5 constraint. For any two shaded cells that share an edge, they must have a difference of at least 5 between them. Finally, we have Japanese sums, where clues outside the grid give the sums of shaded cell segments in the respective row or column in order where unshaded cells separate segments. Okay. Clues outside the grid give the sums of shaded cell segments in the respective row or column in order where unshaded cells separate segments. A question mark indicates any digit from 0 to 9, but no clue may have a leading 0. So that means this clue cannot be 0 because that would have a leading 0. This cannot be 0, 9 here because that would have a leading 0. But it could be 1, this could be 10 as a value because it does not have a leading 0. So the question mark stands for a digit, and the first digit can never be 0, essentially. An asterisk denotes an arbitrary number of Japanese sum clues. This could be 0, 1, or multiple clues. Interesting. Okay. So that means in, for example, column 4, you could have multiple numbers of sums, an arbitrary number of Japanese sums clues. It could be 0, so that means we could have just one segment of shaded cells in column 4, or it could be as many as you want. In this case, it could be 4, right? And then this would have to add up to a 2-digit sum for this segment. Obviously, that doesn't quite work, so there's a problem there. But the question mark, or sorry, the asterisk could stand for 0 clues. So it could be just one clue actually is in one Japanese sum clues in this column. It could stand for multiple clues too. So this would actually kind of work because you could have these 4 represented by the asterisk, and then the last sum here is basically a double-digit sum for the last segment. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. One thing we know is a shaded... So since the shaded cells act as a whisper 5 line, 5 can never be on a whisper 5 line. So, what does that mean? In yin-yang shading, there has to basically be... Okay, so 5 is in every row and column. So therefore, you cannot have a full column or row be completely shaded, because we are guaranteed there has to be a 5 in that row or column, and 5 can never be on a whisper 5 line next to another digit in normal Sudoku. So because of that, we also know on yin-yang shading, you have to have basically, you'll have to swap. You can only swap up to twice on the edge of a grid in yin-yang shading. And the reason why you know that, so we know there's basically a 2-digit set here. So say this was shaded here, we have this being unshaded, and then we had another shading here, and then we had unshaded here. How do you orthogonally connect the green regions without making the blue regions break into two different segments? And the answer is you cannot. It's because if you try to orthogonally connect the green regions, this will necessarily break the blue regions into 2 segments. So that's why you can have, at most, 2 changes of shades in a yin-yang shading. So therefore, we know, we are guaranteed then that you cannot swap colors here. Well, we don't know if it's basically swapping somewhere here. And before the end of this must swap. So this has to be sum. It could be sum here and then go to there and then swap. It has to swap somewhere in this row because you can't have all unshaded, or you can't have all shaded cells in that row. So they must swap here, which means this is shaded. Sorry, this is unshaded. And it's the same with this way. It could be something like this, right? But we know this is guaranteed to be unshaded. We don't know about the shadings here. So this must be 2 sets. Okay, so this is 1 set of shading. This is 1 set of shading 2. So once it starts shading, it has to continue shading. This has 2 digits. This is a singleton digit, so this is at least 2, at least 2, at least 2. This is at least 2 cells. This must be at least 2 cells and 2 cells. So this cannot be shaded. If this is shaded, that forces this to be shaded. These would all have to be shaded to connect with this. And then this would have to be 2 digits to be shaded there. So this cannot be shaded here. Therefore, we have 3 cells which are in the 2x2 area, none of which are shaded. So therefore, this must be shaded here. Since this is shaded, this is guaranteed to be a 2-cell shading here. This could be shaded here if this is unshaded. That is possible. This could be green. We don't know about this. So obviously it cannot be shaded here. Oh, this is a 2-cell shading because the last shading has to be 2 cells. So this is shaded. It cannot be shaded here because then that would be a 2x2 area that's all shaded. This is unshaded, so this must be a 2x2 area to be a 2-digit number, so that's shaded there. Since this is shaded, this must continue shading down here, which means it must continue shading at least 2 here. This can't be shaded because of the 2x2 that has 3 shaded cells. Same with this. This is unshaded here. That means it must change shading here. Therefore, this cannot be shaded at all. This 2x2 area is all unshaded. So this must be shaded here. One thing also about yin-yang shading is if you have a diagonal which is the same shading, you cannot have a diagonal of the other shading being that way. So this cannot be blue and blue. It has to be one of the same shading and then one of a different shading. And the way you know that is, say this was 2 shaded. If we have both of them being shaded the same shading, it's a 2x2 area that is all the same shading, which is not allowed. If you try to have both of them being the opposite shading, how do you orthogonally connect them as regions without breaking apart the other shading? You can't, right? Because this would form one region and this would form another region. So that's why you can't have 1 and 1 on either side. So, that's why you can't have 2 of the same shading be on the other diagonal. So therefore, this then has to be green because it cannot be the blue shading. So this is green and green. We have blue going here. This already has 1 there, but we can have any number of things there. These have to be... So we're guaranteed a 5 has to be one of these 2. These are all, actually, 1, 2, 3, 4, 5, 6. All of these digits are in between 2 unique digits on a Whisper 5 scenario, right? This is next to those 2. 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 Same with this is next to those 2. This is next to those 2. Therefore, they cannot be 4 and 6. So this must be 1, 2, 3, 7, 8, 9. Which leaves these digits remaining as 4, 5, and 6. So this is 4, 6, this is 4, 5, 6, this is 4, 5, or 6. This is going to be one shading. And then you'll have to alternate between these cells then. So let's mark this. We'll mark this as orange. Actually, let's mark this as pink. We'll mark these as orange. So on a Whisper 5 line, you need to alternate between low digits and high digits because what digits can be next to low digits, which are 1 through 4 on a Whisper 5 line? Well, 1 could be next to 6 through 9, 2 could be next to 7 through 9, 3 could be next to 8 or 9, and 4 could be next to 9, all of which are high digits. So next to a low digit must be a high digit. And for 6 through 9, what are the possibilities? 6 could be next to 1, 7 could be next to 1 or 2, 8 could be next to 1 through 3, and 9 could be next to 1 through 4, which are all low digits. So you'll always alternate between low digits and high digits on a Whisper 5 line. So this is pink. These have to be all orange. And these must be pink. Well, if this were 6, that would guarantee this is 6 plus 1, which adds up to 7. But 7 is not a 2-digit number. So therefore, this cannot be 6. It has to be 4 and 9. So the pinks are all low, and the oranges are all high. So then this is 4, this is 9. That forces this to be 9 here. This must be 1, 2, 3 as a triplet. This can't be 1, 2, 3, cannot be 9, therefore this is 7 and 8. This digit must be able to be next to both 7 and 8, so it cannot be 3 there. So this is a 2-digit number. This can't be 4, so this is 5, 6 as a pair. This has to be 1, 2, or 3. This is 7 or 8 there. This has to be 7 or... It has to be next to... Well, we don't know if it is next to anything. This cannot be 6. If it's 6, that would force this to be 1. That would not sum up to a 2-digit number. So this has to be 7 or 8. Okay. Let's see. This is 4 and 9. Remaining digits in this box are 1, 2, 3, 7, 8. This digit also must be next to 7 and 8. So this cannot be 3. Where is a 3 in row 1? It has to be here, which is next to 8, which makes this 7. 7 eliminates 7 here, so that's 8. That adds up to 13. That's fine. How does this work here? So this could be 2 and 8, and then that's done. That is possible. What's the furthest this could go down? I think the answer is... You could have 8, 3, 9, 4. Or 8, 1, 2... Or 8, 3, 9, 1, 2... blank. So the problem with... Okay, so you cannot have more than 3 lows in this column. If you tried to have a 4th low, that wouldn't be... 4 would then have to be there. 4 would have to be next to 9. You would have 2 other lows, but the 3 here could not be next to both 8 and 9, which it would have to be connected. So that means you can have at most 3 lows, which means you could have 3 highs, and that works. So these could all be part of the shaded region, but these cannot be. So therefore, this is not shaded. Therefore, this is shaded. For it to be on the yin-yang shading, so this is blue, you'll have essentially checkerboard pattern, right, of things which can be on the yin-yang shading. Because you'll always alternate between low and high digits, right? It will always, to get to a certain cell and still be on the yin-yang shading, it has to be a certain thing. So this has to be all high digits. So this would be high, low, high, and low. This would be then high, low, high, and low. So this has to be low guaranteed. So this is 1 through 4. This is 1 through 4. But if this continues as a low here, it would be 3. So this is not shaded here. This is at most blue and red. It could be blue, red, blue, but it cannot be blue, red, blue, red because two high digits would add up to at least a two-digit number when we know that the sum is a one-digit number. But it could continue this way, so we don't know. Um, hmm. This is a two-digit number. That works because 9 and X is fine. You could have blue, blue, blue. That is possible. So what happens if we have this scenario? So this would be red, blue, and red, which would force that to be blue, that to be blue there. 3 would have to be one of these two, and then 3 cannot be here because it would guaranteed be next to a 7 or 9. So then this would have to be 3. We'd have to have 9 here. This would be 1 or 2. And then this would be 7. Which would be next to a 1 or 2. So then this would have to be red. Because this is not a two-digit number yet. This would have to be 3 or 4. This would not be shaded because it wouldn't... This would have to not be shaded also. So that's looking okay. This would have to be 6 or 8. So that would be fine. Hmm. That seems fine. Didn't lead to contradiction there. This cannot go the full way this way, so it has to basically be somewhere here. Hmm. Um... Huh. Okay, this can't be 8. Remaining digits of box 1 are 3, 4, 5, 6, and 9. 9 cannot be either of these. Hmm. Okay. We have to figure out this shading. Um... This has to cross over eventually. Right? This is 3 at most. It has to cross over. Could do something like that, which is fine. Huh. Obviously, it could just be a single digit by itself. That's fine too. This can't be 4. If this is 4, that would guarantee it has to be next to 9 on a Whisper 5 line, so one of these would have to be 9 to be orthogonally connected to the rest of the shaded regions. But this can't be 9 because of 9 in the column, and if this is 4 and 9, that would add up to a 2-digit number. So this is 1, 2, or 3. It could be 3 and 8 going that way. That is possible. So that would be the only way that you could have 3 and 8. Can you have 3 digits going this way? I don't think so, actually, thinking about it. You have to have 2 lows, which is 1 and 2, and then you would have to have a high digit, which would be 7 at minimum. 1, 2, and 7 add up to a 2-digit number. So it's 2 at most going this way, and then it turns here. So either it goes this way and turns, because it has to have 2 digits at least in the shaded regions, or it goes these two and then turns that way. So either way, this is definitely unshaded. And it has to be a 2-digit number. So it can't go 3 there and then turn. It has to go 2 and then turn, or this way and then turn. Because this is 2 digits at least. We don't know if it goes this... That's interesting. So if it goes this way, all of these... If this goes this way, it has to be all of them are... have to be, like, form a region, right? So say what happens if we have that. Okay. Well, then this would be green. That would force this to be blue. That would force this to be green. That would force this to be blue, which would force this to be green because of the 2x2 areas. Therefore, it would have to connect that way. This then could not be 3 in that scenario. So that's interesting. What happens if we don't have that as green? Or sorry, don't have that as part of the shading. So then this has to be red. Let's say then we went up here. Then that's blue, red, that's green. Blue, red. This would be red, green, red. So that would force this not to be shading. So that also works. That's interesting. Huh. But it could be any pattern like that. It would have to be something like some weird ass thing. Okay, we don't have any guaranteed shadings from this then. This is the only guaranteed shading here. Okay. What happens if this is all shaded here? That's possible, right? Let's take a look. So say that's blue, red, and blue. This obviously couldn't be shaded because then this wouldn't be 2 distinct areas. So this would have to be green. This would be red. That would force this to be green here, and that would be a contradiction because this cannot be adding up to a 2-digit number. So it cannot go all the way down to here. So that means if we tried going all the way down to here, obviously it can't be 3 cells here because that's 1217 at minimum. So this can never be shaded. Okay, so since this can't be shaded, this has to be shaded. It's red. This must be shaded because of the 2x2 area, so that's red. This can't be shaded because it's a 2x2 area, so this cannot be 3 anymore. This is next to 2 unique digits on a Whisper 5 line, but it could be 7 or 8. It cannot be 9 because 9 and 1 add up to a 2-digit number at minimum, so therefore this is 7 or 8. This cannot be unshaded because it's the 2x2 area. So this could be 8 and 1. This can't be 7. It's 6 or 9 here. And it has to be a 2-digit sum at least, so this is shaded. This is not 3 unique digits, so this has to be connected there. Therefore, it's connected to 2 unique digits. Therefore, this is 9. This is a 2x2 area that is all shaded. That is 3 shaded, so this cannot be shaded. That's unshaded. 2x2 area that has 3 unshaded, so this is shaded, and it's blue. So these are connected. This is connected to 2 unique digits, 1, 2, and 3. So 3 has to be one of these 2 digits because we have a 1, 2, 3 triplet in column 8. So, and this must, one of these is 3 then, so this can't be 8, this can't be 7, it's 8, which forces this to be 7, which is next to 2 unique digits, 1 and 2, on the Whisper 5 line. This is a 3-digit number though, so this cannot be red, blue by itself, so this must be at least red. This has to be a 2-digit number, so this must be connected. That's red. Therefore, this 2x2 area has 3 shaded cells, so this can't be shaded. These are both shaded here, so therefore this cannot be, one must be shaded, one must be unshaded. This is unshaded, so this must be shaded and is red. 8 cannot be here. No 8 here. This is next to 2 unique digits, so it's 1, 2, or 3. This is 7 or 8. I guess this could be 6 also. This is next to 2 unique digits on a Whisper 5 line, so it's 7 or 8. Remaining digits in column 8 are 4, 5, and 6. So this 2x2 area is has 3 unshaded, so this must be shaded and is blue. It could go down here. This has to be 6, 8, or 9. Cannot be 9 because of 9 in the column. So this must be 1, 2, or 3 to be at most next to a 6. Or sorry, to an 8. Huh. So we have 3 this way. This is guaranteed to add up to a 2-digit number, so that's fine. This we don't know how many. It could just be the full set. Actually, it cannot be the full set. If it were the full set, the problem is that this green would be broken up into 2 separate regions. Green has to go out here to be orthogonally connected. This is a singleton digit. So we have to have 2 here, 2 here, 2 here at least. Okay. Um, this has to be a singleton. Well, we don't know. You could have 2, 1, and 1. That could work. It could be many digits. So this is at least 2. It could be just 2. It could be just 2 and 1, or 2 and 1, or 2 and 1. We don't have anything more information here. This is 1. So this has to be at least 2 and 1. So it could be all 4. Yeah, it could be all 4. No, it cannot be all 4. If it's all 4 shaded, that means this has to connect this way. And that would break this off, but then you'd have to have this connecting that way. So it cannot be all 4 shaded. Can you have 3 shaded? Maybe. Like that? That could work. You can't have... Okay, can you have 3 shaded this way? Can you actually ever have 2 shaded here? So say you have shaded... This is shaded. That means these are shaded here. But then the problem is this green has to orthogonally connect to the rest of the green, and it's blocked from this area. So it has to connect orthogonally that way. But then the problem is this has to connect orthogonally to the rest of the blues, or the rest of the shaded. And then this would not be one continuous set. So this cannot be shaded, guaranteed. That means this is shaded guaranteed, so it would have to be red. This could connect all the way down here, or could just connect straight from there, right? So this is guaranteed to be red, and it's next to a blue in one of these 2 spaces, or in both of them. This is not connected. This has to connect to a singleton amount, but it could be something like that. That is possible. Oh. Well, okay, so what happens if we try to make this shaded? So then this would be red, blue, right? That would be red. This would have to be blue, but this would have to have a shading of 2. Well, not necessarily. It could be red. It could be blocked off. So then this is all green. This is red and blue that way. And then this connects here. So that is possible. So if that's the case, then this has to be green. But that doesn't tell us much, right? So then we have blue, red, blue there. That would force this to be green. So it cannot connect, then that would be green. Therefore, this would be red, blue. This could just go straight down here, right? No, because then they would have a 2x2 area. Okay, so then that does not work. We'd have a 2x2 area that is all unshaded. That is 3 unshaded, so this would have to be shaded. Therefore, this would be red, blue, red, blue. This would then have to be green. And then that would fail because we don't have one continuous space adding up to a 2-digit sum. So this cannot be shaded either. Okay. Um, can this actually ever be shaded? No. So if we tried shading this way, so have all of these shaded, that would force this to be unshaded and this to be unshaded, but then this doesn't add up to a 2-digit sum. So that fails. So this cannot be shaded, so this must go out this way. You could have it going this way. That is potentially... Wait, no. If you have red here, and you tried to go up, it has to continue, so it's red, blue. This would have to be unshaded, and this would have to be unshaded because of the 2x2 boxes, but that would form all of these to be unshaded, which is not allowed. So this cannot go up. So this is green also. That makes this blue. You could go around there. That is possible. This must be a 2-digit sum, so this has to go up. So this is red there, which means this is blue to form one full area. That makes this green because of the 2x2 area there. Either that's blue or that's blue. So this is fine. This has to be 7 or 9 next to 2 unique digits. Cannot be 7. So this is 9. That means this can't be 6, so this has to be 8 next to 2 unique digits in a Whisper 5 line. So this is 1, 2, or 3. This is... could be 1 through 4. We don't know. And this one of these is 4. So one of these has to be 4 in row 8, because we have a 1, 2, 3, 4 triplet in that row. And this is guaranteed to be 4, so that forces this to be 9. So this cannot be 9. This is 7 or 8 here. We have a 7 or... could be 6. No, 6 would be necessarily only next to a single digit, 1. So that's why it can't be 6. This 9 eliminates 9 in the rest of the column. 9 cannot be here. 9 cannot be here. 9 is one of these two cells. 9 can't be here or here, so 9 is one of these 4 cells. Where is 9 in column? In box 9. Can't be here because 9's in the column. Can't be here or here, so 9 has to be there. 4 is guaranteed to be one of these two. Remaining digits in row 8 are 5 through 8. This can't be 7 because of a 7 in the box. This can't be 8 because of 8 in the box. This can't be 8 because of 8 in the box. Whereas the 8 in row 8, it has to be here. Which means where's the 8 in row 9? Cannot be any of these because of the 8 in the box. Can't be here because of the way that the 8 works there. So it has to be one of these two digits there. Because it can't be 8 here because of 8 in the column. Okay. This, so one of these has to be going up, connecting, right? This is a 2-digit number, so that's already done. Green has to connect somewhere. This is a 2-digit 2x2 area that has 3 unshaded, so this must be shaded and is low. So this has to be 1, 2, or 3 here. These are diagonally across from each other, are the same shading, so this cannot be unshaded, so this must be shaded. And it has to be 1, 2, or 3 because it's not next to a 9. So we have all of these. It could do something like that. That is possible. No, green has to be able to exit out and orthogonally connect, so this is blocking there. This doesn't have to connect to any of this. So green has to orthogonally connect eventually to here. So that means, and we know there's an additional one here, but it could do something funky like that. Except it really can't. We need, well, this could be a 2-digit number, and that would be satisfied. So it could do something like that, and that would be satisfied. Okay. One of these three. So if this were the... it has to pop up to one of these three. And... so if it pops up here... Right, it could just be these... this is connected all the way there. So that's kind of satisfied too. Remaining digits in box 9, we have 3, 4, 5, and 6. Because 8 is guaranteed to be one of these, and we have 1, 2, 7, and 9 already. 4 obviously can't be here. So 4 has to be one of these two. That's interesting. Okay, is there a possibility to have 2 and then 1 here, and then this is the star? Or even 2, 1, 1? I think no, right? So say we try 2, 1, 1. This has to orthogonally connect. So I guess this would be high. And this would have to orthogonally connect. So that actually kind of works. Yeah, that actually kind of works. Huh. So that could work. Obviously, it cannot be full here. Okay, which ones are fully satisfied? This is essentially, well, kind of done. This is done here. This is done, and that's done. This is done with that. This is done. That is a 2-digit number. This is not. This part is done. We know this has to be a singleton here. If this is shaded, this is a 2x2 area that has 3 shaded, so that can't be, that would have to be unshaded. And then this would be unshaded. If this is shaded, again, you have a 2x2 area here and here, which has 3 shaded, so therefore these would be unshaded. Same with this. This is 2x2 area that's shaded here. Therefore, you have 3 shaded. This would be unshaded and unshaded because this must be a 1 singleton. We don't have anything related to here. This is all done. Okay, so then it's just this part and this part. This is done. Yeah. So it's just this part and this part. So we have any of these three could potentially work. We have the 2, 1, 1, 1 works. So that's interesting. What happens if this is shaded? Does that work? Well, didn't we run into that situation where it does? Think so. Yeah. What happens if this is shaded? Then neither of these are shaded. This has to orthogonally connect. And then this would be a set. So this would have to be red, blue. Wait, not red, blue. This would be blue. That would be red. So this could work. Oh, hold up. We know this can't be 8. So this has to be 1 or 2 here. This cannot be 3 because it's next to 6 or 7 on the Whisper 5 line. So we have a 1, 2, 1, 2 pair, which eliminates 1 and 2 in the rest of the column. Okay. That doesn't help us. Huh. 3 eliminates 3 here. So we have a 1, 2, 1, 2 pair this way, which eliminates 1 and 2 in the rest of the row. So that leaves only 3 through 6 here. Interesting. Okay. Huh. Hmm. Remaining digits in column 7 are 3, 5, 6, 7, 8. Hmm. Um. Huh. Oh, wait. No, that works. You'd have 4 and 9 here. This would be 1, 2, or 3. Hmm. What happens if this is red? Then this becomes green, green. This must be green out there. That forces this to be green. Um, hmm. This cannot be 7. This has to be 6 or 7 here. That means this can't be 3. It's 1 or 2. I mean, that seems fine. This would have to be shaded because of 2 by 2 area. This would have to be unshaded because of 2 by 2 area. This would be a diagonal of shading, so this or unshaded, so this has to be unshaded here. Therefore, this would have to be diagonal of blue. Um, Ah, then this wouldn't work. That would have to be at minimum 3 because we have the 1-2 pair in the box, which would be next to 6 or 7 on the Whisper 5 line, which doesn't work. So this, wow, that was pretty convoluted. So this cannot be shaded. What about this? Maybe it'll lead to something else also. No 9, no 7. So then this is unshaded. This has to, or I guess it could do something weird like that. That is possible. Let's continue with this. Maybe this will help. So if we have this, then we have to have that. This is connected. This is green because of the 2x2 area. So this is 3, and this is 9. That makes this 1 through 4 here. That 9 would eliminate 9 here. So this would have to be 9 here. This would be 9. 3 would eliminate 3 here, so it's 7, which makes that 8. No 7 or 3 here. It's 1 or 2. No 7 here because of 7 in the box. None of these are 3. So far, this is looking fine. If this were... okay. You cannot shade... okay, then that would not work. You have to orthogonally connect the green region, and then this would be only one region that adds up to a 2-digit sum. So no, that does not work. Okay, so then we have that. This can't be shaded. Can this be shaded? Yeah, possibly. It could just be like that. The reason why this didn't work is it had that. And then the problem is this couldn't be shaded. So to connect the green, you had to connect all the way this way, right? And this was blocking that off. This can go this way. That is perfectly fine, right? And that doesn't block this part off. So it was really just this portion that was the problem here. Okay. So it could be 2, and then 1 there. Where is 8 in column 5? It has to be one of these 3. That's interesting. This can't be 8 because of the 7-8 pair in the row. Hmm. So this could connect something like that. Let's take a look at if this is shaded. So then this is unshaded. This has to be... oh, that's interesting. This must be shaded here, then this must be shaded here. Okay. So then this would have to be unshaded this way to connect. This would have to be between two unique digits on a Whisper 5 line. So with this, so this would be 7, 8 as a pair. So this would have to be 1, 2. You'd have 1, 2, 3 here. Okay. That means this could not be 8. You'd have a 1, 2, 3 triplet in row 6. So this couldn't be 3. You would guarantee one of these is 3, so this could not be 3 here, no 3 here, no 3 here, no 3 here. This could not be 9, so one of these two would be 9, so this couldn't be 9, therefore this would have to be 9 there. This is looking okay. One of these two must be shaded because we have two unshaded here. But it could be here or it could be here. We don't know. Oh, cannot be here because then this would be 4 because we already have 1, 2, 3 as a low. So this has to be high. It cannot be 9 because then this would be a 2-digit number. So this has to orthogonally connect. It must orthogonally connect out that way, then that way. This cannot be 9. It could be 8. But if it's 8, this is 7 and 2 at most, which is not a 2-digit number, so this can't be 8. So this would have to be 6 or 7. That would mean this is guaranteed to be a 1. So this would be 1. This could not be 1 here. This could not be 1 here. That would mean this is not 1 there. So far, this is looking fine. One of these must be shaded. We don't know which. Could be both, actually. So far, this is looking fine. No, these both cannot be shaded because one of them has to exit out. But one of them's shaded, one of them's unshaded. This is 1, so this cannot be 1 here. This look is looking kosher. What if we try the other route? So say this was shaded. That means this is unshaded here. This cannot be 7 or 8. It's 6 or 8. So there. Oh. Well, it's a singleton. That's fine. 6 or 8. If this is shaded here, so then this would be red, blue. Green has to be able to connect orthogonally, so it would have to connect out that way. This would be blue and red. This could not be 9, so it's 6, 7, or 8. This can't be 6 because if that was 6, that would be a 1. And then this would not add up to a 2-digit number. So it's 7, 8. So that forces this to be 6. And that's a fail because that's next to 2 unique digits on a Whisper 5 line. So if we have shading here, neither of these can be shaded. Right, if this is shaded, it has to be a 2-digit number, so it would have to go there. If this is shaded, then this would be a diagonal both shaded, so therefore this would have to be shaded because this is unshaded. So this cannot be shaded then. This must extend to at least here. So that could work. This would have to be shaded because of the 2x2 area. Let's see, this would be 7, 8, or 9 next to 1 through 4. Huh. Some of these must be shaded. That's interesting. How would this work? It could be connected there. Huh. Would that actually work? You have to orthogonally connect to here and then here. Right? You could have 3 and 9 there. That could work. What happens if you go this way? The problem with that is this would be 3. You'd have to have 4 here next to a 9, which doesn't work. So it cannot go this way around. But it could go around. So it can't connect here because then... So how would this connect? It can't, right? So assuming this, the green has to be orthogonally connected to this part. So it has to extend to here. So if we have that be unshaded, this would then be shaded because of 2x2 space, but then this would have to be unshaded to connect, so that doesn't work. So this cannot be unshaded, it must be shaded, which would force that to be 3. If we try connecting here, then this would have to be unshaded, but again, that would have to be 4, and it would have to connect to a 9 in one of these spots, which is not allowed. So this has to be shaded. These are both shaded. This can be shaded or unshaded. The problem is, I guess it could be unshaded here. Okay, can this be unshaded? And then this is shaded. Maybe. Yeah, that works. Oh no, this has to be unshaded because of 2x2 space. So then this is unshaded, this is 9. This then has to, sorry, it's shaded, and that's 9. This is unshaded here. One of these two must be shaded. If this is shaded, this is unshaded. And that's unshaded and it connects. Ah, and then we have a fail. So say this was the shaded. Then this would have to be unshaded to orthogonally connect. This would be unshaded because of a 2x2 area, but to orthogonally connect, you would have to be unshaded, and therefore you have a 2x2 area that's all unshaded. And it's the same way if you do the other way. If this is blue, this is green here, this must orthogonally connect, so it's green, and it must orthogonally connect, so it's green, that's 2x2 area, which is unshaded. So you cannot go this way. So this is unshaded. Therefore, this is shaded. That's again 1, 2, or 3. You have a 2 by 2 area that is unshaded. That is 3 unshaded, so this must be shaded. Therefore, this is a 2-digit number at least, so that's 2-digit there. It cannot be next to 1, 2. It cannot. It's next to 2 unique digits, so it cannot be 9. So this is 7 or 8 as a pair. Therefore, this can't be 3. This is 1, 2, 3 to be next to that. So one of these is guaranteed to be 3 here. This cannot be 9. So one of these is 9, which eliminates 9 here, whereas the 9 in box 1, it can only be here. So that's 9. We're guaranteed a 3 here, so this cannot be 3 here, no 3 here, no 3 here, because one of these is 3. We have a 1, 2, 3 triplet here. What do we have here? This is at least 2. We don't have to orthogonally connect this. Remaining digits in box 4 are 4, 5, 6, and 9. Obviously, 9 cannot be either of these. We have a 1, 2 pair in 7, 8 pair. This 8 eliminates 8 here, so this must be 8 here. We have a 4, 5, 6 triplet in column 2, which eliminates 4, 5, 6 in the rest of the column. This can't be 4. It's 1 or 2. Where's the 4 in row 8? It has to be here. So this is 4. Where's the 3 in row 8? It has to be here. Okay. This is at least 2. Where is the last 1, 2 in column 1? None of these can be 1, 2 because of the 1, 2, 3 triplet. This can't be 1, 2 because of the 1, 2 pair. And this can't be 1, 2 because of the 1, 2 pairs in the rows. So this has to be the remaining 1, 2. Where is 7 in column 1? Can't be here because of 7 in the box. Can't be here because of 7, 8 pair in the box. Can't be here because of 7 in the row. So 7 has to be here, which means this can't be 7 here. The green has to go this way to orthogonally connect. So then this must be 8 and 2 to add up to a 2-digit number. That's 8 and 2. That's 1, which makes this 2, makes that 1. So that makes that 2, which makes that 1. 2 eliminates 2 here, so it's 1. 1 eliminates 1 here, so that's 2, which makes this 1. This cannot be 2 here, so this is a 1, 3 pair. This is 3, 4, 5, or 6. 1 eliminates 1 here and here, so this is 2, 3 as a pair. Okay, we have to orthogonally connect to one of these. So one of these is guaranteed to be shaded. Could be both, I guess. No, it cannot be both. One is shaded, one is unshaded. So to do that, if this were shaded, this would be unshaded. These 3 would be unshaded. And it would connect. If this is shaded, so say we had shaded here. If we have shaded here, this would be unshaded here. Sorry, this would be shaded here because of the diagonal. This would obviously be unshaded. You have to orthogonally connect. And then we don't know which one of these would work. If this were 8, this would be 7 and 1. If this were 9, it would add up to a 2-digit number, which it can't. So if this were 8, this would have to be... Okay, this... Well, hold up. Well, we don't know that this is shaded or unshaded, right? We're just looking at this path. So then this is adding up to a 2-digit number. It cannot be 7 and 1. It must be 3 and 8 here. So this is 3 and 8, which makes this 2, which makes that 1. That kind of works. This could not be 9 because that would be a 2-digit number. So then this has to be 6 or 7. Cannot be, it has to be 7 next to a 2 there. So that seems fine. Also, okay, hold up. So let's not do that yet. This can't be 3 because of the 1, 2, 3 triplet in the row. What are the remaining digits? We have 4 through 9. Okay, 4 through 9, 4 through 9, 4 through 9. No 4, 8, or 9 here. So this cannot be connected to here. Because if it were connected to this, this is not going to be 5 away from that. So therefore, this is not in the set. So this must be then 3 and 8. Cannot be 7 and 1 because that adds up to a 1-digit number. Therefore, this is 8. Sorry, not 3 and 7. 3 and 8, which makes this 7 and that 1. This can't be 1. Can't be 3 because it's next to a 7, so this is 2, which forces this to be 1. So no 8 here. No 8 here, no 8 here. This 7 eliminates 7 here, so this is 8. Which eliminates 8 here. So where's the 8 in row 8? It has to be there. Okay. This can't be 3, it's 2, which forces this to be 3 there, which makes that a 7. This cannot be 7 here. It's a 5, 6 pair in column 7, so this can't be 5 or 6. It's 3. That eliminates 3 here, and 3 here. This 7 eliminates 7 here, and 3 here, so this is 1, 2 as a pair. Okay. So that's 11. If this connects to here, it cannot be 9. Where is 8 in box 5? It has to be here. So this is 8. That gives us a lot of 8s. That gives us all the 8s. And that was the reason why we knew that was 8 was because we had 8 8s. This can't be 9 here because of 9 in the box. Remaining digits of column 9 are 3 through 7. This can't be 7 because of 7 in the row. 3 eliminates 3 being there. So I think almost everything is done. One of these two is shaded. Oh, this cannot be shaded because 3 can only be next to 2 unique digits on the Whisper 5 line. So this cannot be shaded, which means we have a 2x2 space that is that is 3 unshaded, so this must be shaded here and is blue, which means it must be next to... This must orthogonally connect, so we have to go out that way. Okay, these are diagonally opposed to each other, but they're shaded, and this is unshaded, so this must be shaded there. Which means it cannot be 4, 5, it cannot be 9, because 9 and 1 add up to a digit number, so it's 6, 7 as a pair. We have a 5, 6, 7 triplet in row 5, 4, which eliminates 5, 6, 7 in the rest of the row, so this is 4. This can't be 4, 5, or 6, it's 9. Therefore, this is 9 here. This 6, 7 pair eliminates 6 and 7 in the rest of the box, so this can't be 6 or 7. That's 5, which makes this 6, which makes that 7, which makes that 6. This has to be 2 to share an edge. One of these two is shaded. 2 eliminates 2 here, so that's 1 and 2. 4 and 4, 6 eliminate 4 and 6 here, so it's 5. This can't be 4, 5, or 6. It's 3, which makes that 7. 4 eliminates 4 here, so this must be 4 here. 5 eliminates 5 here, so it's 6 and 5. 5 eliminates 5 here, so it's 6 and 5, which eliminates 5 here, so that's 6. 6 eliminates all of these from being 6, so where is the 6 in box 7? It has to be here. That eliminates 6 in the column. Okay. This 6 eliminates 6 in the rest of the row, so this is a 4, 5 pair, which forces this to be 3. This can't be 4, 5, or 9, so that makes that 6, which makes this a 4. 6 eliminates 6 here. Where is the 6 in box 1? It has to be here. This can no longer be orthogonally connected to there because that would be difference of less than 5. So this must be green. We have a 2 by 2 area that is all green, so this can't be green here. It's low. And this must orthogonally connect to the rest of the green cells. And this must then be a 3 because it has to be 5 or more away from 8. That eliminates 3 here and 3 here. So where's 3 in row 7? It must be here. And the rest we probably can do from normal Sudoku. We have 8 ones. We know where the last one has to be. It has to be there. We should have 8 twos. We know where the last 2 has to be. It has to be there. We have all 9 threes. 4s, we don't have very many, but 4 in column 5 cannot be here because of 4s in the boxes, and these are filled out. So this must be 4, which makes this 5, which makes that 4, which makes that 5. That makes that 4, which makes that 5, which makes that 4. And we should have all 9 4s now. We do. 5s. Where's 5 in row 9? These are filled out. And it cannot be here because of 5 in the column, so 5 has to be there. We give 8 5s. We know where the last 5 has to be. It has to be there. 6s. We have 8 6s. We know where the last 6 is. It has to be there. And 7s are the remaining digits. So this is 7, and that's 7. And that's the solution. Yeah, I'm not very good with Japanese sums, so it takes me quite a while to do these sort of things, but... I thought this looked interesting, and it was. It was a very interesting puzzle here. So, a lot of deductions you had to make, with not very much logic, or not very many clues. But it was very satisfying all around, I guess. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.